Good day, students. Welcome to part 2 of the Algebra 1 Common Core for the June 2014 Regents exam. We're going to be going over problems 6 to 10. Don't forget to visit our website at mathgotserved.com for a collection of a wide variety of tutorials ranging from algebra to calculus. All right, let's take a look at question number 6. It says, the table below shows the average yearly balance in savings account where interest is compounded annually. No money is deposited or withdrawn after the initial amount is deposited. So you have the years going from 0 to 50, and they have the balance in dollars. It says, which type of function best models the given data? Is it a linear function with a negative rate of change, linear function with a positive rate of change, exponential decay, and exponential growth? All right, so let me classify how these four options behave, and then we're going to see which of the descriptions match this data set that we have in this table above. All right, so what does it look like when you have option number 1, linear function with negative rate of change? Well, since the function is linear, the rate at which the rate of change is going to be changing is going to be constant. Okay, so for option number 1, we're going to have, well, since it's negative rate of change, linear function is going to be decreasing. Let's go ahead and change that. So decreasing at a constant rate. Okay, so linear function is decreasing at a constant rate. All right, now how do I know it's decreasing? Because it says negative. And how do I know the rate of change is constant? Because it's a linear function, it's a line. Okay, linear function with a positive rate of change. In this case, it's going to be increasing. All right, so at what rate is the function increasing? Since it's a linear function, it's going to be increasing at a constant rate. All right, the rate of change on the line on a linear function is always the same at every point. Okay, so that's why we have constancy in the rate of increment or decrement in options 1 and 2. Option 3, exponential decay. You see this decay basically means that it's going down, is decreasing. But the thing about exponential function is the rate of increment or decrement always increases. All right, so exponential decay is basically, decay means it's getting less, so it's decreasing at an increasing rate. All right, linear is constant rate of increase or decrease, but exponential is increasing rate of increase or decreasing. Now, exponential growth, what does growth indicate? It's increasing, right? It's increasing, since it's an exponential function, is going to be increasing at an increasing rate. All right, so the slope basically keeps getting steeper and steeper the more you go out on an exponential function. Now let's put some numbers to this description here. If you look at the balance, what's happening? Is it increasing or decreasing? You see the numbers are increasing, right? So any of these options that involves the function decreasing should be eliminated. So what can we eliminate? Eliminate option 1, that's decreasing. And then let's see what else. Decay, take that out. So it's either option 2 or 4. They are both increasing. What's going to tell us is that we're going to look at the rate of increase here. If it's constant for all the years from 0 to 50, then our answer will be option 2. But if it's increasing, then our answer will be option number 4. Okay, so let's go ahead and see the rate of increase. All right, so let's look at it from 0 to 10 years. So how do we know the increase? You just subtract 562, the final amount minus the initial amount, 380. And the increase is 182. Okay, now from 10 years to 20 years, what's the increase? 8 32, the final amount minus the initial amount, which is 562. What do you notice is happening here? Are these two rates of increase the same? The answer is no. It's increasing at an increasing rate. Okay, let's do just one more just to illustrate. So from 20 to 30 years, you take the final, and then you subtract the initial, which is 832.63. Oh wow, it's going higher. Okay, so let's go ahead and write this down. The increment from 0 to 10 years was 182. And then the rate of increase from 10 to 20 years, the increment from 10 to 20 years was, what was it, 270.14. And then the rate of change from 20 to 30 was 399.86. So what do you notice about the rate of increase? This is increasing, right? It's increasing at an increasing rate. Is it linear or exponential? The answer is exponential. Notice increasing at an increasing rate. So answer is option number 4. If all these numbers were the same, then guess what? Our answer will be option 2, because option 2 is increasing at a constant rate. All right, so this is not the answer because our rate of change is increasing. All right, so that's that. All right, let's take a look at problem 7. It says a company that manufactures radios first pays a startup cost and then spends a certain amount of money to manufacture each radio. If the cost of manufacturing R radios is given by the function C of R equals 5.25 R plus 125, then the value of 525 best represents, remember the formula for cost per unit? The cost per unit is basically, the total cost is basically price, unit price multiplied by quantity. All right, so which of these numbers is being multiplied by the quantity over and over and over again? For example, the cost of 1 unit, you're going to have 5.25 times what? Times 1 plus 125. What do you notice here? You notice that 5.25 is being multiplied by the quantity. Cost of multiplying 2 radios, 5.25 times 2. What are you multiplying the quantity by? 5.25 again. So what, if you take a look at this formula right here, the quantity keeps changing, but what do you keep multiplying by the quantity over and over again? You keep multiplying this value right here. And guess what this is? This amount, 5.25, is the price to manufacture each radio. Okay, price to manufacture each radio. So you can think about it as unit cost. Okay, price to manufacture each radio. You always multiply the unit cost by the number of radios you produce. If you produce R radios, you multiply the unit cost by R radios. All right, so let's look at the options right here. 5.25 represents the unit price, or the price or amount to manufacture each radio. Okay, so let's see which one matches that description. Startup cost, the profit earned, the amount spent to manufacture each radio, the average number of radios manufactured. So we can clearly see the answer is option 3, the amount spent, or you can think about it as price and amount are the same thing, to manufacture each radio. All right, so the question is, how about this 125 in this cost function? What does it mean? It never changes, right? So the price that never changes, that is constant regardless of how many radios you manufacture, is known as your startup cost. Startup cost doesn't depend on the number of radios you make. Okay, So startup cost is 125. That's option number one. So let's say in this problem, you were asked to describe what 125 represents. 125 is your startup cost. You have to have that cost in order to start your manufacturing, regardless of how many radio sets you produce. And the thing about startup cost is once you have it, that's it. You don't have to, it doesn't change, it stays the same. All right, so the correct answer for this problem is option number 3. Okay, let's take a look at problem number 8. It says, which equation has the same solution as x squared minus 6x minus 12 equals 0? Now this is already in standard form, but the options are in vertex form. Okay, so all we are just doing here is we're going to just transform this equation into this form right here. Okay, these forms are completed squares. They are completed squares. Completed squares. How do I know that they're completed squares? Because you can clearly see that every quantity is squared. Okay, so what this problem is simply asking you to do is complete the square. Okay, express this equation in vertex form, so to speak, this quadratic that's in standard form. So in order to do that, first step in completing the square is you want to create an incomplete square. All right, so to do that, I don't know if this square is complete, so I'm going to take this 12 out of there and put it to the side. So I add 12 to both sides of my equation. And then I have x squared minus 6x equals 12. Now I have to find a number that completes the square here. Okay, and I'll of course add it to both sides. Now if the number were 12, if the number were negative 12, guess what? It's going to cancel that number, this number out, and then it'll turn out to be that this was in fact a perfect square trinomial, and then we'll have it equal to 0. But if we get something else, we just go ahead and complete the square. Okay, so let me rewrite this again. So we have x squared minus 6x equals 12. Adding 12 to both sides. Now I want to complete the square on the left side, so I have to add a number that makes this a perfect square trinomial. And then in order to preserve equality, I have to add that same number to the right side. So this is basically completing the square algorithm. Now what number completes the square of an incomplete square? You just simply add b over 2 square to both sides, and on the left side you will have a complete square. In this problem, what is b? On the left side, see this form right here, you have a 1, that's a. That's a. The coefficient of x is always b, so our b is negative 6. Think about the quadratic formula. When you want to use the quadratic formula, remember a is a coefficient of x squared, b is a coefficient of x, the same procedure here. So we're going to add b over 2 squared to both sides, so b is negative 6. What do we do with that? We divide it by 2, which is negative 3, and then we square it, and we get 9. Now this completes the square on the left side of the equation. So we add a 9 here, and then we add a 9 here. What do we have on the left side? We have a perfect square trinomial. So what's special about a perfect square trinomial? Where you can easily factor a perfect square trinomial using a factoring trick. What is that? You just take the square root of the first term and the last term and bring down the middle sign, and you're done. Okay? What is the square root of x squared? X, the middle sign is a minus, square root of 9, 3, quantity square. When you have a perfect square trinomial, you can factor it in a second. Just root the first and the last, bring down the first sign, and you're done. Okay? 12 plus 9 is 21. And guess what? We already have completed the square. So these two equations are exactly the same, but they just have different forms. All right? So let's see. Which of these options matches this form? The this vertex form here, is option number 2. All right, let's take a look at problem 9. It says the ball is thrown into the air from the edge of a 48-foot high cliff so that it eventually lands on the ground. The graph below shows the height y of the ball from the ground after x seconds. So the question is, for which interval is the ball's height always decreasing? Okay, so decreasing just basically means you're going down from left to right. Okay, going down from left to right. If you're going up from left to right, then you're increasing. So think about it as though you're driving a car, okay, and you have your headlights shining out. When your headlights are pointing downhill, then you know you're decreasing. Okay, if your headlight is pointing straight forward, is pointing horizontally or upwards, then you're not decreasing. Okay, so let me give you an example. Let's say you have your car right here. This is your car on the hill. Where's your headlight facing? Your headlight is facing up. So guess what you're doing? You are increasing because that's where your headlight is facing, okay? Facing up, you're increasing all the way to, how about when you get to the top of the hill? Right here. And you have your car. Where is your headlight pointing or facing? Your headlight is going to be pointing straight horizontally, like that. So you know what that means? That means you're neither increasing nor decreasing, okay? But when you get to this side of the hill, where is your headlight facing? Your headlight is facing down. So what does that mean? It means you're decreasing. So on what interval is your headlight facing down? That's the interval that you're decreasing, okay? So the interval where your headlight is facing down starts from this point right here all the way to this point right here. Okay, so that entire interval is an interval where you are decreasing because your car is kind of facing down. Okay, so you're going from uphill to downhill, so you're decreasing on that interval. So it looks like this looks like 2.5. So from 2.5 all the way to 5.5. Okay, so let's look at the options that we have. We're going to go from 2.5. Remember, we do not include 2.5 because at that point, you are neither increasing nor decreasing. So your lower bound, if I can get my color straight, is 2.5 excluded all the way to 5.5. Answer is option letter 3. Option number 3. Okay? So that's the correct answer for you. All right, let's take a look at problem number 10. It says, what are the roots of the equation x squared plus 4x minus 16 equals 0? So to find the roots of a quadratic equation as illustrated here, there are many ways you can go about it. Okay, you can factor, you can graph, you can complete the square, or use the quadratic formula. If you look at the options, you notice that there are radicals involved. Anytime you have radicals or imaginary numbers, then factoring will not work for you there. So you just have to use other methods. So if you're confused as to what method to use, or you are having difficulty factoring, you can always know that the quadratic formula always works nicely. Completing the square always works, but the quadratic formula is the simplified process of completing the square. So there's no need to complete the square if you have the quadratic formula, okay? So let's go ahead and write down what the quadratic formula is. The formula is x equals negative b plus or minus the square root of b squared minus 4ac. There are a lot of songs for this formula online. You can learn. Divided by 2a to help you remember it. All right. This is an easy formula to remember, but the problem is using it correctly. Now that's where a lot of students make mistakes. Minor errors with signs and the order of operations. Okay, so all we need to use the quadratic formula is a, b, and c. So since we have x squared plus 4x minus 16, remember you must set it equal to 0 or have your quadratic in standard form first before you find a, b, and c. Okay, is this in standard form? It absolutely is. Equal to 0, degrees are in descending order. coefficient of the squared variable is a, coefficient of x is b, and then the constant is c. So we have a situation where a is equal to 1, b is equal to 4, and c is equal to negative 16. Pay close attention to your negative integer values because that's where students make a lot of mistakes, okay? Now let's plug it into our quadratic formula. Negative b is minus 4 plus or minus the square root of 4 squared minus 4 times a is 1 times c negative 16. Keep a special eye on this negative 16 right here so you don't mess up, all right? Another mistake most students make is they just divide one side by 2a. That's inaccurate. You have to divide the entire numerator expression by 2a, and a is 1, so 2 times 1. Okay, so that's the setup right there. After finding the values of a, b, and c and plugging it into the quadratic formula, the rest is simply arithmetic. So using the order of operations, let's deal with this radical piece here, plus or minus the square root. 4 squared is 16. Minus times minus is plus. 4 times 16 is 64. That divided by 2. Now what we can do is we can split up this denominator to both terms here. So we're going to have negative 4 over 2 plus or minus the square root of 16 plus 64 is 80 divided by 2. Okay? So negative 4 over 2 is negative 2 plus or minus. Now can we simplify the square root of 80? Let's go ahead and do that on the side here. Root 80, I'm going to take out prime factors. It's even, so I can take out a 2. Take out 2, you're left with 40. Take out another 2, you're left with what? 20. Take out another 2, you're left with 10. Take out another 2, you're left with 5, which is a prime, so let's leave it alone. Any factors that repeat are squares, and we can root them to just be left with one factor, okay? So 2 times 2 is 4, that's a square. 2 times 2, the square root of 2 times 2 is 2, if you root that. Oh, we have another 2 and 2 here. 2 times 2 is 4. If you root those 2, you just get 2. 5 is by itself. It's not a square, so it stays behind as a radicand. So the square root of 80 is basically these two numbers that we were able to root. 2 times 2, root 5, which was what we had left here. Okay? So what we're doing right now is basically simplifying our radical expression. So we have, let me just divvy up my workspace so we don't get it mixed up. Okay, so 2 times 2 is 4, 4 root 5. So the simplified form of root 80 is 4 root 5. Okay, so that's what we're going to put over here. We have, instead of root 80, we have plus or minus 4 root 5 divided by 2. And then we're going to have negative 2 plus or minus, this 2 divides with that 2 twice, 2 root 5. Negative 2 plus or minus 2 root 5 is your final answer. And our answer is option number, let me see, number 2, right here. Because remember we divided this 4. You see this 4 and these 2 right here? We divided those out, so that's why we had plus or minus 2 root 5. So you have to be really careful with your reduction, okay? Alright, so our answer is option number 2. Thanks so much for taking the time to watch this presentation. Really appreciate it. Do feel free to subscribe to our channel for updates to other free tutorials such as this. And do post a comment to let us know what you think about this tutorial. More clips can be found on mathgotserved.com/testprep. Thanks again for watching and have a wonderful day.